So continuing on our modular arithmetic stint here, the common example when we're starting to learn about modular arithmetic is using our clock. And so just to draw us a quick, very unartistic clock here. Here is basically our clock from day-to-day life. Now, you're used to using this clock. We also have the 24-hour clock, which can be something to say something like it's 1600 hours. It's 16 o'clock, and this is the same as 4 p.m. So the reason I know it's the same as 4 p.m. is because once I get to 12, and I need to keep going on this clock, I just keep going around. So 1 is actually 1300, 1400, 1500, and 1600 hours is here at 4 p.m. When I'm just looking quickly at something like, if somebody says it's 23 o'clock, then what I'm doing in my head is I'm just taking 23 and I'm subtracting 12 and saying, oh, actually that's 11 p.m. Okay. Now, let's look at something a little weirder on a clock. What if I said instead that it's 46 o'clock? Now, the savvy user will see some patterns here, but so 4600 hours, I can't just subtract 12. I have to figure out how many times 46 goes into 12 and then how many are left over. So I know how many full times that go around the clock and then how many more are left. So what I'm actually doing for math is this. Dividing by 12. Now 12 times 4 is 48, so I know I'm at 36. So this is 3 with a remainder of 10, which means it's actually 10 o'clock. That's what 4600 hours is, 10 o'clock. Okay, on this clock. So this is the classic example of how we use modular arithmetic, which is also sometimes called clock arithmetic because of this clock. In the next video, we'll see some different examples of mod with some different bases, different bases other than base 12.